Good afternoon, ladies and gentlemen, Algebra 2 honors. We're moving on from quadratic functions straight to section 5.3, which has to do with solving linear systems in 3 variables. Who knows what a system of equations is? Anybody?
What is like where you have like 2 functions and you've got to figure out the solution, like where they cross?
Yeah, so Jay just said, in fact he demonstrated here, he says if you have 2 equations, in this case of lines, if you can see where they cross, that xy coordinate pair is that solution. So basically it's a set of equations with more than one variable. That's what a system is. Now what we're doing here is we're extending your prior knowledge and going into a system with 3 variables. And so here we have the essential question: how can you find the solution or solutions of a system with 3 linear equations in 3 variables? And then the techniques we're going to be using are solving by substitution, which is where we're going to concentrate today's instruction, and also elimination. And finally we're going to go to technology with matrices, where you're going to use your calculator and solve systems using your calculator. And most people really like that last section. And so, but we're going to start with substitution today. Now, when you have an equation with 3 variables, you're talking about the equation of a plane. If you have 2 variables, you're talking about a line. And so here are some different possibilities of what can happen if you have a system with 3 equations and 3 variables. You can have no solutions where essentially the planes are just parallel to each other. You can have a system where you have 2 of the planes parallel but 1 not, so you have 2 lines of your solution set. And then you can have your planes set up like this, so you'll get 3 lines as possible solutions for that. But the one that we are more commonly seeing in this class and in your career as mathematicians is going to be this one, where there's going to be 1 point in common with each of those planes, which will be the solution. And we're going to see other examples too. So basically the book takes us through solving by substitution, but I'm going to go right to it and go to a system with 3 variables right here and just start working on this, and we'll kind of talk through this. Stop me if you have questions. You can stop me right this second if you need to. Yes. No. Let's try it. Okay. So, the technique of solving by substitution has to do with getting 1 variable by itself first, and then just kind of working downstream from there. And so, what I'm going to do is I'm going to start out with this first equation right up here, and I'm going to solve this equation for x. And basically what I'm looking for in my first equation is I'm just looking if it's there for just a single isolated variable like this. Now it's not totally isolated yet, but I can get this x isolated by moving this 2y over here like this, and also moving this z over here to the other side. And what happens when we move variables to the other side? They change signs, right? So what we're going to have is x, we've moved 2y over to the other side, so we have negative 2y. And we move z to the other side, we'll have minus z, and we still retain this plus 8 right over here. Okay, so we've got x by itself now. All right. And what I'm going to do now is parenthesize this thing right here. You might ask me why I'm doing that, or might know why I'm doing that. Why am I doing that? No, I'm not going to factor anything out, but I'll show you next. Okay, now we're going to carry over this solve for x equation and substitute it in to this second equation. So I'm going to come to the right here, and I'm going to write 2, and then I'm going to leave a space right here like this. And I'm going to put plus y minus z is equal to 4. Okay, why did I leave this big blank here?
You're going to subtract that y minus z minus.
So the way I did it, so I could just plunk this thing right in the place of this x. So x is this in parentheses, and here's the x here. So I'm going to put minus 2y minus z, and finally plus 8. Do you see that? Is that legible? Sometimes the z looks a little bit like a 2, doesn't it? But I'm going to cross-hatch those z's to make them more legible, I hope, okay? All right? Does everybody get that so far? Okay, the next thing I'm going to do is I'm going to distribute here and get this simplified here. So I'll take that, that, and that. So I'm going to get 2 times negative 2y, or negative 4y, and 2 times negative z will be minus 2z, and then 2 times 8 is 16. And then I have plus y minus z is equal to 4. Any questions on that so far? And correct me if I'm wrong, because especially in the second period today, I made some little mistakes. Mostly because I was just paying attention to answering questions and discussing with the audience more. So here we combine our like terms. So negative 4y plus y is negative 3y, and negative 2z minus z is minus 3z, and then we have this 16 plus 16 is equal to 4. And then what? Subtract 16, right? So we have negative 3y minus 3z, and if we subtract 16, 4 minus 16, we get negative 12. Now, is there something you can do to make your life easier with this equation right here? Any ideas? Yeah, so Ben just said it. If we divide this equation by negative 3, the whole equation, what do we get? We'll get y plus z equals, and negative 12 divided by negative 3, 4. Okay? Okay, next thing we're going to do is take this equation here. And so I'm going to just rewrite an open parentheses here. And I'm going to put plus y plus 3z is equal to 7. What is going to go in this parentheses here? This value of x here, right? So negative 2y minus z plus 8. Okay. Do I need to slow down or anything? Is that okay? A little bit? Want me just to hold still right here? Okay, let's look at this now. So now we have negative 2y, and see here, we don't have to distribute anything, do we? So we can just take this negative 2y plus y is negative y, and then we have negative z plus 3z is plus 2z, and then we have 8 plus 32 is, no, 8 plus, excuse me, plus 8 equals 7. That's not 32, that's 3z. I'm going to caught by my mistake. Okay, then what?
Subtract 8.
Subtract 8, so we have negative y plus 2z is equal to negative 1. All right? So now we've distilled everything down to this system here. And you remember last week we worked on another system equation. Remember that? What was that? You remember what that was when we worked with quadratic functions? What was that system equation we worked with? We had to solve for a and k, right? Remember that? Well, well, now we just have two equations, so we can solve for, you want to solve for y? So y is going to be equal to 4 minus z. Okay, I'm going to put that in parentheses here. And then what can we do with that? We can replace this y here, can't we? So negative, open parentheses, plus 2z is equal to negative 1. And what goes in here?
4 minus z.
4 minus z. And then so we have negative 4 plus z plus 2z equals negative 1, is that right? So on the left, if we add, we got negative 4 plus 3z is equal to negative 1. And then if we add 4, we get 3z is equal to 3, and therefore z is equal to
1.
Z is equal to 1. Now, are we all done?
No.
No, because we have to go back, right? So to me, a very simple way to go back would be going to right here, right? So if we take this thing right here and substitute in z for 1, we're going to have y is equal to 4 minus 1, which equals 3. So y is therefore equal to 3. Now are we done?
Yes.
Not quite, because we need to find yet x. So if we write x plus 2y plus z is equal to 8, we can take this y here, this 3 for y, substitute here, this 1 for z, substitute here for z. So we have x plus 2 times 3 plus 1 for z is equal to 8. So that gives us x plus 7 is equal to 8. And so x is equal to
1.
x is equal to 1. And so now have we solved for everything?
Yes.
What's the last thing we need to do for this?
Plug it all in.
Yeah, plug it all in and check your answers, right? So x is 1, right? So that's 1 and y is 3. So 1 plus 2 times 3 is
8.
7,
Oh,
and 7 plus 1 is 8. Check. And you similarly do the same. 2 times x, that's 1, that's 2, plus 3, so 2 plus 3 is 5, minus 1 is 4, check. And finally we have 1 plus 3 equals 7, check. So they all check. So what do we know our answers are? X equals 1, y equals 3, and the first thing that we solved for was z equals 1, right? And then what happens is our answer is going to be in the form of what we call a coordinate triple, not a coordinate pair, but the answer is going to be the coordinate triple 1, comma 3, comma 1. So that's a coordinate triple answer. In my other classes today, I think we started out solving for z instead of x. But did we end up in the same place?
yep.
Yeah, we did. And we tested. So what I want to do with the remainder of class time, really, well, I want to answer any questions you might have first.
So why is it in that coordinate triple form, like the answer, why is that 1, 3, 1?
Well, because, okay, Bryce asked why we have this answer in coordinate triple form. You could just, the boxed in x equals 1, y equals 3, and y equals, z equals 1, you could do that. But when you put this in a coordinate triple, that emphasizes your understanding that this is a coordinate, this is a location in a coordinate volume with x, y, z. So it's a matter of what you emphasize. I don't know if that was a good answer to your question. Yes, sir.
If z equals 1 and x equals 1, why are they different letters?
Okay, let's take, okay, Ben asked a question, if x equals 1 and z equals 1, why are they different letters? What I'm going to do is I'm going to try to demonstrate what that is over here. Is what happens is, I guess I can't show you too much here, but if you have like an x and a y and then a z, you can imagine this coordinate coming out perpendicularly to that xy, right?
Oh, it's 3.
So you get x, y, and z. So when you talk about 1, 3, 1, you go x is 1, and then y is 3, but then you come over 1 unit in the z direction. So that point's going to reside right here as 1, 3, 1.
So it's like the 3.
It's like a 3D coordinate pair, but a coordinate triple, because it's triple. So 3D coordinates is what it is, yeah. And so it's really an extension of where your knowledge and understanding is taking you so far. Okay? That's some good questions right there. And what happened is the summer before last, I took a course in linear algebra, which really, it's a very high-level mathematical college course that goes over systems of equations, essentially. So what I want to do next is turn you loose on another system of equations and just have you work on it. And so here it is. I want you to work on this system and see where you get. Pardon me? Okay, Marcus asked the question, does it matter which one goes first? No, it doesn't. But I will tell you that in this case, you only have one equation where you actually have a single variable, like one of them, right? So my recommendation would be to start with this first one and solve for y. In fact, I'll start out by doing that for you. If we add y over here and subtract 1 over here, what we're going to get is 2x minus, well, actually, minus 3z minus 1 equals y. So this negative y over on the other side of the equal sign becomes positive y. And this positive 1 over here going the other side gets to be minus 1. Thank you, Jose.
Is that neat?
How many of these did you sell, Jose?
Not much.
Not much?
Where are they?
Do I need to sign that someplace, Jose?
Away from the illegal way.
Jose, you're bringing that into class. You're making me hungry. You know you're making me hungry, Jose, right? He doesn't care. Jose doesn't care he's making me hungry. He says, yeah, you're a grown man. You can deal with it, right?
You should make this your salsa for the last game.
Make the salsa for last day?
We had just heard it.
Okay, look at here. This is what Jose brought for me today.
Oh, yeah, Jose.
This is spiral sliced ham. He's making it hungry.
Bust it out.
Watch out the ham.
Okay, so you're working on this, right?
Lay it down.
And what I'll do toward the end of class, I'll show you a solution to this. And yeah, so it'll be pretty much the rest of class, right? So basically you can work on this for about 10 minutes or so. And by my experience, some of you will probably be finished. I think I had one person in 7th period who finished. And you know who that person was? Steve-O. Steve-O.
Me neither.
He whispered it. Connor, how'd you hear?
What?
Whisper too loud.
93?
So did I.
How'd you get there?
So 93, right? He must have been
Good job, Eddie. On the other side. I probably cheated. We were sitting halfway across from. Halfway?
What about the two guys sitting close to each other that got 90s? That's the one I'm worried about.
Oh,
We
Connor.
do the same. We really do. Like everything.
Oh, really?
And if we'll be in like an opposite class, like in one class, I can't remember which one it is, but like last year, they're the same grade. Like all years.
So you think the same way or something like that? Or are you just like psychic twins or
It's
something?
weird.
Yeah, he gave me this.
You weren't ready. Doing it right. So, you walk in, we'll get I didn't answer half of it.
I answered almost everything.
I answered most things.
Most everything. I did all the.
I answered most of them. They weren't happy. You just there, but then the last, the very last one.
Ew. Oh my god. Oh my.
Okay, Jay.
Is there,
So, what's up?
I got stuck.
You got stuck?
Yep, on the part that I wasn't here for.
You're stuck?
Yeah.
Where did you get stuck?
The first part, like whenever you,
I would say I did the factor where I was.
Okay, let me go ahead a little bit here. So right now, what we're going to do is take this one and plunk this in the place of this y here. Okay? So 4x plus 3, that's 3. And I'm going to open the parentheses wide here for that, plus 2z is equal to negative 4. So this is going to go right here in the place of this y, which is going to be 2x minus 3z minus 1. Okay, is that legible enough? Okay. And then I'm going to do the same thing with this equation here. So I'm going to take negative 3x plus 2, leave that open parentheses gap here, plus 5z is equal to negative 3. So I'm going to put that right in here, which is 2x, and I'm going to put this in parentheses up here, of 2x minus 3z minus 1, so that's 3 right there. Okay? And then just continue simplifying down, and when you simplify down here, you're going to have two equations in terms of x and z. And then you'll be able to solve that system, and I don't know which one you're going to, depends on which one is easiest to solve for once you get it. Did you get that far? Did you finish it?
Yeah.
I think you finished it. Anybody else? You almost? You're stuck? Okay. Do you need me to keep working up here, or a little bit? I'll do this. I'll just get these ones worked down, because here we have 4x plus, that's 3 times 2x, that'll be 6x, and 3 times negative 3z is minus 9z, and then 3 times negative 1 is minus 3, plus 2z is equal to negative 4. And just combining the like terms, we get 10x, and then negative 7z plus 2z is going to be minus, or negative 9z plus 2z is going to be minus 7z, minus 3 equals negative 4. And then adding 3, we got 10x minus 7z is equal to negative 1. Is that right? Then this one here, you have negative 3x plus 4x, and then you have 2 times negative 3, which is negative 6z, and 2 times negative 1 is minus 2. Then you have plus 5z is equal to negative 3. And then you add these together, you get x, negative 3x plus 4x. And then you have negative 6z plus 5z, so that's going to be minus z. And then you have minus 2 equals negative 3. And then you add 2, you get x minus z is equal to negative 3 plus 2, or negative 1. And so now you have these two equations, right? Where you can take x equals z minus 1, take this z minus 1, bring it right in here for this x, and then you can go solve for x. And then you work backwards. All right, does that make sense? How many got at least this far?
Once you got the first, once you told me how to, when we plugged it into the parentheses, the first time I got it.
You got it there?
Yeah.
Okay. And we're going to get to the point where we're going to solve by elimination also, which to me, I think is a little easier most of the time. We'll get to that. What I want to do with time running out in the class, I'm just going to shift to all the solution I have here. Will that be okay for you?
Yeah.
Okay. So here's the whole solution here, right? Which is the same thing done earlier. We have x equals z minus 1, plugged it back in here for this, solve for z, and once you solve for z equals 3, you come over here, and then you have x solved for. And then with x and z, you can plug it into this top equation, and you distill down y equals negative 6. Is that what you got for your answer here?
Yeah.
Who else got this for an answer? Right?
I didn't use it.
You didn't quite get that far?
I got it for an answer.
Pardon me?
I got it.
All right, good deal, man. That was awesome work. So really, what do you think of today's work? You think it's kind of okay, or?
Yeah, once you told me that what was doing the second part, I understood.
Okay, good.
At least we know she heard.
Damn, Steve,